Okay, so lesson 4 in Unit 2, we're going to be solving equations with variables on both sides. So that means an equation where x is on the left side of the equation, x is on the right-hand side of the equation. We are also going to identify equations that are called identities or equations that have no solutions at all. So it'd be nice to know what an identity is. So an identity is an equation that is true and it's true for every possible value of the variable. So every value of the variable. Okay, so it's an equation that's true no matter what. So for our first examples, we're going to talk about how to solve when x is on the left and x is on the right. So before we were talking about isolating x. In this situation, I would want to get the x's to be on the same side of the equation. So what that means is, and this might help, is to draw some sort of line to distinguish, split the sides of the equation up, and I would want to get 2x on the other side or to get 5x on the other side. So what I'm going to do is I'm going to subtract 2x from both sides because I know that 2x minus 2x is 0. So the other side of the equation becomes 3x plus 2 equals 14. So what I did was I canceled out 2x on the right-hand side, I subtracted it on the left-hand side, and I got 3x. From there, the solving becomes a little bit simpler. I get 3x equals 12. I divide by 3 on both sides. I get x equals 4. Okay? So, for part B of this example, you may want to pause the video. I'll stop for a few seconds. If you want to pause it and try this example, that might be a good idea, but I'm going to explain this one and kind of my steps. So for part B, I'm going to draw my line just to distinguish the sides of the equation, and then I'm going to think about either moving 4k to the other side or moving 7k to the other side. So I'm going to move 4k to the other side by subtracting 4k from both sides. So this becomes 3k plus 2 equals, and what's left on this side is negative 10. That's important to recognize that is negative 10. So for me to solve this, I'm going to subtract 2. 3k equals negative 12. And then finally, I divide by 3. So in the end, k is negative 4. And that is my solution. All right, so get the variables to be on the same side. So mainly, to move a variable term from one side to the other, you're either adding or subtracting to move that variable. So in example 2, it says it takes a graphic designer 1.5 hours to make one page of a website. Using new software, the designer could complete each page in 1.25 hours, 1.25 hours. But it takes 8 hours to learn the software. So how many web pages would the designer have to make in order to save time using the new software? So what we're going to do is we're first going to define a variable. And the question here explicitly asks, how many web pages? So it may be a good idea to define maybe p as your variable, and that is the number of web pages that each designer, or that the designer needs to make, all right? So I'm going to have an equation on the left, and an expression on the left and an expression on the right. So if it takes them 1.5 hours to make one page with the old software, I would represent that with the expression 1.5 times p. And then set that equal to the new software, okay? So 1.5 hours per page times p pages. That's how many pages I can make in a certain amount of hours. Using the new software, he could complete each page in 1.25 hours. So that would be 1.25 times h, but it takes him 8 extra hours just to learn the software. So that adds 8 hours to his time. So each expression represents time, but our variable represents the number of pages. And I just realized I wrote h instead of p. I'm sorry about that. That should be a p, 1.25p. So I've got my equation. Now I can solve it. I'm going to subtract 1.25p from each side. So let's cancel. This becomes 0.25p equals 8. Then I finish it off by dividing both sides by 0.25. So p equals, and if you want to use a calculator, that's fine. Dividing by a fourth is like multiplying by 4. So it would take 32 pages. Okay? It would take them 32 pages to take the same amount of time. So after 32 pages, that's when it would be saving us time, the new software. So the idea is that the new software, yes, it takes time to learn, that 8 hours to learn, but you can complete the web pages much faster using that software. So for a certain amount of time, the new software is actually slower because you're taking up that 8 hours of time to learn how to use it. So in this next example, if you want, take a minute, try to set up and solve the equation on your own. Otherwise, just follow along and try and just pay attention to how I define the variables and then how I set up the equation and solve it, okay? So in this one it says an office manager spent $650 on a new energy-saving copier that will reduce the monthly electric bill from the office from $112 to $88. In how many months will the copier pay for itself? So for us to solve this equation, or to set up the equation, I would want to define the variable, and I'm going to define my variable as m. I'm going to define that variable as m, and that's going to stand for months. Okay? So when we talk about this, we want to talk about the old bill and the new bill and compare them. We want to find out when those bills are equal. So he spent $650 on the copier itself, on the new copier. So the cost of that copier in total for us is going to be the $650 for the initial cost plus $88 a month as a recurring cost. Okay, so it's cheaper each month. And we're comparing that, setting it equal to, comparing it to the old copier, which cost us $112 per month. So the initial cost is great, but then eventually this copier is going to be cheaper. We're going to figure out how long it takes for that copier to become cheaper. So for me to solve this, I like to draw my line, and then I'm going to move 88m to the other side. The way I would do that, since it's addition, I'm going to subtract 88m from both sides. So I get 650 equals, this becomes 24m. Okay, 24m. So for me to finish solving that, I'm going to divide both sides by 24. And you're going to notice something here. It doesn't divide nicely, does it? We get something like 27.083 repeating. Well, if we're thinking about this in terms of months, I would say that this would take 27 whole months at least. It would take about 27 months. Sorry about that bell, guys. It would take about 27 months for that copier to pay for itself, kind of, all right? So when you get a problem like this, we're going to talk about it takes 27 full months. That 28th month, it's going to be cheaper, all right? Moving ahead to the next page. Now we've got some equations with grouping symbols, all right? So I'm going to do one, and then I'm going to have you try one on your own. So in example 3 here, part A, I would simplify both sides first. On the left-hand side, I would distribute 7. So this becomes 28 minus 7a equals, I'd multiply through 3a minus 12. And then I talk about getting my variables on the same side. So if I were to move 3a to the other side, I would subtract 3a. If I were to move 7a to the other side, I would add 7a. So you can do either one. What I'm going to do for this one specifically, I'm going to add 7a to both sides. So this becomes 28 equals, add 7a. So this is 10a minus 12. And then it's just a two-step equation from there. Add 12 to both sides. Oop, that's 40. That's 40. 40 equals 10a. I divide by 10 to finish solving. I get a equals 4. Okay, I get a equals 4. For part B, I'm going to distribute on both sides. Actually, I'm going to let you guys, I'm going to take a minute and just pause for a second and let you guys try and solve that one. Another good time to pause the video and solve it, and then check your answers with me in a few seconds. Okay, so I'm going to simplify the left-hand side. That becomes 8y plus 4. If I distribute, the other side becomes 2y minus 26. Okay, so it's up to you. You can subtract 8y from both sides to get the y's on the same side, or you could subtract 2y from both sides. So what I would do, I would subtract 2y from both sides. Okay, so this would become 6y plus 4 equals negative 26. And then I would subtract 4 from both sides. This would become 6y equals negative 30. And then finally divide by 6. So that y equals negative 5. Okay? So that's solving. It's important to be careful on what variable you're moving and what operation you're using, because once you get the variables on the same side and you combine those like terms, the equation becomes, I think, much simpler. Okay? So every equation we've solved up to this point has had exactly one solution. A equals 4 is one solution. Y equals negative 5 is one solution. The next step is to talk about equations that may have no solutions, okay? Or an equation that's an identity. So we're going to notice something special about these equations, right? So in example 4, part A, when I'm going into this equation, I want to distribute 2 through that side first. So I got 10x plus 12. This equals 10x plus 12. And something you notice is going to happen, okay? These two equations, both sides are exactly equivalent. So at this point, we know that both sides are the same, right? Exactly the same. If we continue to solve like we had been, I would subtract 10x from both sides. 10x minus 10x is 0. 10x minus 10x is 0. And I get 12 equals 12. So what this actually means is that no matter what, this equation will be true. No matter what I plug in, no matter what number I substitute in, this equation will be true. So this equation is an identity. It is true for whatever value of x I choose. I could pick any number for x, and this equation will be true. So then part B, I'm going to distribute first. Okay, and that's going to be 12b minus 6 equals negative 6 plus 12b. Sorry about the bell again. This is going to be negative 6 plus 12b. That didn't have to simplify at all. And then I'm going to think about what happens when I solve this one. I'm going to subtract 12b from either side. I notice that 12b minus 12b is 0. 12b minus 12b is 0. and I get negative 6 equals negative 6. Again, if you notice before, these are equivalent. They're the same value. So this one is also an identity. This is true for whatever value of b I choose. And then finally, this last one. I am going to distribute on the right-hand side. I'm going to distribute negative 1. So this left-hand side stays 2x plus 7. The right-hand side becomes negative 3 plus 2x. And I'm going to solve it just like I had been before. I'm going to subtract 2x from both sides. And if you notice, 2x minus 2x is 0. 2x minus 2x is 0. This results in an equation that is not true. This equation is not true. So if that is the case, where my result is a number that is set equal to an unequal number, no matter what I plug in for x, this will not have solutions. So this equation, we would say, has no solutions. Okay? It will never be equal. It will never be true for whatever value of x I choose. Okay? So that's an important thing to remember. Okay? So I'm just going to give you some steps for solving equations in the end here, just so you have something to follow. So the steps to solving equations, I would say your first step is to distribute if needed. So if you need to distribute a number, a quantity through parentheses, do that. Distribute has an E on the end. Distribute if needed, okay? Once you distribute, you can move on to the next step. If you don't need to distribute, skip to step 2, really. So the next step would be to make sure to combine like terms. And that means combine like terms of terms that are on the same side of the equation, okay? Combine like terms on the left-hand side, do it on the right-hand side, make sure that it's simplified, all right? Okay. Your next step, I would say, get the variable terms on the same side. And that's going to be from adding or subtracting. That's how you're going to get the variable terms on the same side. All right? And then solve for the variable using the solving that we had been working on all week, or on the last few lessons, the first, 2 lessons. So that gets us a more familiar equation. And then your final step, and this step is probably important if you're not 100% sure, check your solutions. You can always substitute back in to check your solutions, okay? If you know that you're solving it correctly, that's fine, but it's nice to go back and check and make sure that you're doing it right. Also, you ask yourself the question, is it an identity? What does that look like, you know? Does it have no solutions? What does that look like? Okay, so those are important questions to ask yourself before you move on, okay? So this is a good chance for you to get some practice in and then get ready for that checkpoint. Make sure that you're taking your time on the practice and checking the answer key. Don't just copy down the answers. That's not helping anyone, all right? Make sure you're working through them and checking your answers.